we were working on our chained list remove method. And we said in order to remove a particular position, you had to whip down the list until you reached the one before the one that you were trying to move. So that's why the -1 was there. And this is just advance down the list, going through each one of the links until you reach the one before, and then you need to be careful about having the one before, the one that you're trying to remove, and the one after. And if you get those variables done, then all that you're doing is you're hooking the one before's next to the one after, which gets rid of the middle one. Okay? So the variables help make this thing work. That's the general case. Okay? And when we run the test on that thing, we discover that the test fails in a whole bunch of different ways. And if you look at where the failures are all concerned with what happens on the very first one, just from sort of the names. Okay? And so if we go back and look at the code again, the problem is if you say remove from the 0 position here, you're not removing things, you're not removing something from a node's next, you actually need to play with the start of chain variable. Okay? So there's one piece of code that needs to go in there that says if the current item count, or sorry, if the remove position happens to be the 0 position, then you have to do something special. So in this diagram, this is the 0 position. How do you get rid of the 0 position?
You link the start to the first.
Start needs to refer to B. Who's referring to B? A's next is referring to B. So we'll take A's next value and we'll plop it back into the start variable, which will make start refer to B. Okay, so we'll take start of chain dot next. So start of chain dot whatever I called it. Yep. Next, and we'll put that into start of chain. Okay. Now, it looks a little weird, but if you think of that line of code as being advance the start of chain by 1, just like we did with the current variable, right? That means advance by 1. All it's saying is it's saying take that thing that's pinned at the start and slide it down by 1 position, which basically removes that one. Okay? So that's really just advance by 1. Advance the start of chain variable by 1, and that value is now gone. Then what?
Well, then you have to reduce the item count.
Then the 2 variables that you have at the top of the class are start of chain and item count. We've played with start of chain and done something to it. So item count needs to change, needs to go down by 1. And then we're just going to get out of there. So we'll do that as the special case and we're done. Okay? So almost always with this linked list code, the first item on the list, that 0 position, is a special case when you add and remove because you're playing with the start of chain variable rather than a node's next variable. Okay. That's because I've got some weirdness going on with Git. Okay, and we'll run the test. And now it works. Okay. So there's remove. Questions about remove? Okay, let's try one more. Suppose I want to write the toString. Start out with something empty, send that back, and now figure out how to fill it in. It's a list of things, so we want to produce all of the items on the list. With counted for loop, sure, int I equals 0, I is less than item count. What are you going to add to result?
So you need to start at the beginning of the chain.
You would need to print out current dot.
Name.
Well, we don't have a current variable, so I guess we should make a current variable. What does current need to refer to?
Start of the chain.
Needs to refer to the start of the chain first. And then we'll print out current dot stored item. We'll tack that on to the list. And then what? Current equals current dot next, and you can just get used to writing that. That means advance current by 1, so that it's now slid down to the next thing on the chain. Okay, you can add some fancy stuff onto there if you want, but to print out some brackets and stuff around them so that they don't all run together, I guess we should at the very least add a space there to sort of try to keep them separate. Okay, so there's one version of toString. Do I need to say stored item there? You could leave it off, but then what would you be printing out? Current is a node, so you would be calling nodes toString. Node doesn't have a toString, so that it gets the default one, which is to print out basically the memory address of the node. Okay? If someone says to a node, tell me something interesting about yourself, what would the node say? Not what it is, but
What it refers to.
what it refers to. Nodes are sort of self-deprecating creatures that really don't want to be seen by the real world. So if you come up to a node and say, hey, who are you? It's like, you don't want to know about me, you want to know about stored item. And just to be specific here, we'll put in the toString of that. If I spell stored correctly. Okay, so there's two ways you can play the game. One way to play the game is you can be really specific in the code here and say, I want the node's item, which is the interesting thing. The other way of playing the game is to punt and let node do the work and say, tell me something interesting about yourself, and then node goes, well, yeah, no, you don't want to know about me. This is the important thing about me, which is the thing that I'm trying to hold on to. Okay, so there's another little sort of trick about moving the work down again to somebody who needs to be interested. Okay, so there's one way of doing the toString. What if I want to do it as a while loop? Just let me, I'll leave all of these in here. I guess I can steal this bit. Suppose that I want to write it as a while loop. Still need a current variable to say, here's the important position. Now what does the while loop do? Current or current.next? If the list was completely empty, what would be the value of start?
It would be no.
Null, which would mean while start is not equal to null, not start.next, which refers to the first one on the list. So that one's just while current is not equal to null. The trick that you have with that next field is that when you say current.next, you're actually referring to the one after the one that you're currently on, right? So start of chain dot next refers to the number 1, not the number 0. Okay? So same thing there. We're going to want to tack on that stuff and do it that way. Lost it. Okay, so there it is with a while loop. If you're a traditional C programmer, you're probably more likely to write that with a while loop. Okay, that would be the sort of the standard way to write it rather than with a counted loop. One more way to do this. Let's just duplicate that. And then I'll hide this one. Suppose I want, if you look at this thing carefully, this thing is really, could be written as a for loop, because this is what I need for the start. This is the terminating condition, and this is what I do for each increment in the for loop. Okay, so it's really for node current equals start of chain, current is not equal to null, current equals current dot next. And then that means that this thing all gets wiped out just down to that, hopefully, if I've done it right. What's wrong with that?
You have
You don't have current.
There's no, Curly brace, yeah, that's it. That'll do it. There we go. Okay, so you'll also see it written that way. And this way is fairly typical, again, of C programmers who are more interested in doing something inside this loop other than just that one thing. Okay, so for instance, if you look at Linux kernel code, you'll see a lot of stuff going through chains that looks sort of like this because they do a lot of linked list sort of stuff. Okay, so that one would also happen. Okay, so you have your choice. My recommendation, believe it or not, is that you try a bunch of them for different situations and see which ones make it easier for you. The other recommendation is that you be somewhat consistent. So you'll find me tending to use counted loops. The thing I don't like about this one is that it becomes very hard to see the stuff that's on the line because you can see what's happened already. It's sort of started to disappear because it's fairly long, right? So I tend to prefer one of the other ones. It makes the code a little longer going down the page, but then I don't have to read across the page as much. On the other hand, if you're a C programmer, you get used to seeing this thing as, oh, just go through all of the items that are on the chain and do something. So this is still no different from our idea that loops just process all of the things. Okay. Okay, so there's 3 ways to do that. Now, let's try one more thing with this chained list of things. If we go back and look at this list, and I start retrieving things with get, what's the performance of this thing? If I want to go through and print out all of the elements on this list,
Over
n or n squared.
N squared.
The first time I retrieve the 0, 1, right? So the get says, oh, okay, well, remember that the start of the list is here. We'll go running down the list until we find the one we want. Okay, there's the 0, 1. So that's get 0 finishes. You come back and you say, get me the number 1. The code for get says, oh, we need to go to the start of the chain. We need to, oh, that's not the right one. Let's go one farther. That's the right one. Oh, okay. Got it, return that one. By the time you go get this one, you're now going through the previous ones again. Okay? So notice that that performance of retrieving things in order from 0 through n gives you n squared performance. Did you notice anything about the 2 strings that we were writing? What was the performance of the 2 strings? Big O what? In all of the 2 strings we wrote, see there's get, and every time you call get, it starts at the start of chain. But if you look at what we did for the 2 string, the 2 string goes through the entire chain just once because it's got that current variable standing underneath the appropriate one, and the next time you go through the loop, it just goes and grabs the next and advances and the next and advances. So the 2 string goes through all of them with just big O n rather than n squared. Oh, okay. I wonder if there's a way that we can make going through this thing from the outside world faster. If you had a variable that was persistent, and for instance, if we kept that current variable around all the time, then when you came back and said, get me the next one. Oh, well, that's really easy. This is the one you want, and then I'll just advance current. Okay, so that's what's making this thing efficient, is that this current variable is being remembered all the time that you're going through the loop. Okay, so one of the options is to say, let's put a current variable right at the top. Okay. The problem with that is that only one person could go through that thing at any one time, and you'd have to now have reset current back to the beginning. Or what if you wrote one loop that went partway through, and then you wrote another loop that wanted to go from the beginning, but you wanted to maintain the position of current, right? The fact that there's one variable at the top means that there's only one notion of current. Okay, which is sort of bad news if you want multiple notions of current. So how would we get multiple notions of current? The thing that's going to give us more than one of them is that every time somebody wants a current to refer to some place, you have to do a new of one of those things, so that you can now keep track of that notion of current. So you can have current in one place versus current in a different place, and people can say, well, I'm right currently here. Right? So if we were to come down here and make a private class cursor, then we would say that thing contains a private node current. How would somebody from the outside world get access to that thing?
They wouldn't.
Well,
Only the,
if I change this to public so that people can access it, then I can write public cursor, call it get cursor. Return a new cursor object. Where do you want that cursor object to be positioned to start with?
the starting chain.
Okay, so that now means that somebody from the driver, when they want to go print all of the things out instead of playing this game, they can go, I can't quite do this the way I want, but that's okay, it's going to change. Cursor, what do I want to call it? Sure, current is talk to union and, chained list, which is a, gotta be careful here. I'm just going to change that thing to chained list since we're adding to something other than the default. That'll make it happy. Oops. Yeah, I know. I'll fix that in a moment. Okay, we do something like this. This is actually chained list.cursor. Okay, but it's a cursor from the chain list object is what that dot is doing there. So I would say get the cursor, and then what would I do to go through all of the items? I can't count because I don't know how many there are, but while current dot, make something up. While there's something else. As next. Give me the next one, and then print it out. Just really quickly, there's who. It would look something like that. Does that look familiar? Okay. Well, let's just go in here and write really quickly public Boolean as next, and we'll write public E next, whatever the thing happens to be in this case of a worker. So how do you know if you have another one or not? Current is not equal to null, tells you you have another one. True or false? Okay. How about give me the next one?
Current equals current dot next.
Well, how do you get the next one first? I want to send one back here. Current is standing underneath it, so it's current dot stored item is the one that the cursor is standing underneath, and then the cursor needs to increase, and then return item to return. Oop.
Red run.
Close enough. Okay, so the trick is to say, give me a new one of these objects that now will hold on to a current variable for me, because we wrote that class inside of the other class. It can look at the value of that start of chain, it can look at all of the nodes, but the outside world only says to it, do you have another one? And if it says, if it's standing underneath this one, it says, well, yeah, there is one because it's not null, right? When somebody says, go get me the next one, it says, oh, well, if I'm standing under this one, you want that thing, and now I'm just going to slide current equals current dot next so that the next time you ask me, I'm standing here. Okay? And now current has become persistent, and it's just waiting and standing underneath every single one, and the outside world keeps saying, go fetch, and it just says, that's fine, there's the next one. How efficient is that?
Much more.
It's way more efficient. So this is what kind of thing?
It's an iterator.
It's an iterator. So guess what? Iterators for chained lists are really, really efficient because they're keeping track of where they are. They have some knowledge of the inside of this thing. Okay? So one of the reasons why we're using for each loops for going through bunches of things is it allows the iterator to do the right thing and be more efficient. So we went from n squared performance to order n by using the iterator rather than get. So we'll just finish this off tomorrow and turn it into an actual iterator.
Plug me as well?